Our line trace set up in order to see which light switch in the level we are activating. We have our light actors in place that can now turn themselves off and on when told, but what we don't have at this moment in time are switches that know what lights they should be instructing. And so, let's fix that by, inside the content browser, making sure that we have located the light switch blueprint and have double-clicked on it so as to gain access to its event graph. Now, as with the previous blueprints, we need to put each part of the overall puzzle in place first so that we can then get them all to work together. Before we can do that, of course, we need to create some simple logic to have the light switches communicating with the lights. Let's right-click then, search for the Add Custom Event node, and then add one to the graph, calling this one Light Switch, and then pressing Enter or Return. Just as with the lights themselves, here we are telling the switch what to do via a custom event that can then be triggered via our line trace hitting the switch. In fact, we are essentially aiming to create a cascade of events. So we click the mouse, which fires the trace, which hits the switch, which runs an event that triggers the light event as well, that eventually will turn the light off or on. Now, to do all of that properly, of course, we will need the switch to know which light it is supposed to be communicating with. Inside the Variables tab then, let's click to create a new variable. Call it Lights, and then set the variable type by searching for actor in the list, and from under the object type list, expanding the actor flyout, let's choose the object reference entry. We are using the object reference variable type because it gives us the same functionality as already seen in action with the blueprint's components, only with the added flexibility that it doesn't need the actor to be part of this specific blueprint. We do need to make some changes to this reference, however, meaning we want to click the icon to the right of the variable type so that we can make it an array container. We need to make this change because we would otherwise only be able to have this switch affect a single blueprint in the level. As most visualization projects have multiple lights in them, we want to let the user decide if it affects just one light in the scene or several, and for this we need an array. A variable type that can be thought of as, let's say, an expandable bus with multiple rows and/or columns that can contain multiple seats. Instead of chairs in our case, though, we are storing object references. Still, we are not done with it quite yet, and so coming back to the Variables tab, we want to make this new array public by clicking the eye icon. We can then drag a reference of it into our graph under the custom event, after which we can compile the blueprint via the Compile button. We changed the array to public here as this gives the level designer the ability to place the switch in the level as they like, and then, from the Details tab for the static mesh, pick the light or lights in the level that they want it to affect, making this very easy to use indeed. Now that we have a place to store our lights then, we also need to tell the switch what to do with them. After dragging out from the custom event then, and searching for and adding a for each loop node from the array section, we can pipe our array variable into its array input. We are using the for each loop node here because we want the blueprint to perform the following actions on every single light in the array. Without the for each loop node, this simply would not work. What we need to do next is tell the system what blueprint code it ought to execute. After dragging from the loop body output, we can search for cast2 bp underscore wall underscore light, and then add the node of the same name, making sure that we don't add the class variant of this node. After which, we can pipe the array element from our for each loop node into the object input of the cast2 node. This casting process being how we are going to get the light switch to communicate with the lights themselves. Now that we have cast to each light in the array, we can perform the next step now, which is to left click and drag on the cast2 node's execution output, and then, after releasing the mouse, search for and add a switched custom event to the graph, piping the BP wall light output into the target slot of our new node, and then compiling. We are essentially looking here to see if the lights that sit in our array have the appropriate properties. In our case, the custom event called switched, and then, if they do, execute it. And as easy as that, we have learned how to not only get two blueprints to communicate with each other successfully, but also how to run a custom event.